So as well as 9 times 4, like we say, is going to print out 9. Now, we're going to say the file pointer left at, after it said read in, it's going to move to location at the end of 9 times 4 is what? What location is it? 10, right? It's going to move to location at the end, right? Now, we can write 555 to that location. So it replaces the values. And then we can say in out.length. We move it. Dot length, that means we move to the end. So 555 replace at location contents of 10, right? At location 10. And then when you do a length, it's going to, so let me draw it for you before we get more confusing. So let me start from the beginning on the list. So let's use an Excel, it's better to represent this. So I'm going to start from 0 to 200, right? And then we said file pointer is moved to 0. And get the contents which is 0 out. And so on. So this is the contents. We write 0 to 199. Right? At location 200 to, if we start index 0, then it's going to be the same 1 to 199, right? This is content 0 to 199, which is 200 numbers. Now, when you do in out.seek, we may move the this is the file pointer location pointer. And then when I do read in, it's going to print out 0 right there. And since it's read in, it moves this to that. And when I do 1 times 4, it's actually try to move the pointer to, but this one is in the chunk of 4 bits, right? 4 bytes. Let's say this is a chunk of 4 bytes like that. File pointer actually move by byte, right? So it's actually after it read in, so that's why 4 bytes read in. Move to the end. Before it was pointing to the beginning. Like before when you say seek 0, it's actually right there. File pointer is pointing, which is like here, file pointer, right? And then when it start to get the contents, content is 0, so it's display the contents out, and then move 4 bytes because it's read int at the end right there. So it's moved to the end. I have to say it that way. So now file pointer is pointing right here, which is, if I say, it's pointing right there, right? At the end of the bytes. Which when I do read is actually already read that location, so it's prepared to read the next one. Now, why it has 2 times 4? Because this is 4 bytes for integers. Each box here is like 4 bytes. Right? We can see it's all 4 bytes. Like that, a box of 4 bytes that we copy right here. It's a box of 4 bytes for int up to the last one. Right? And file pointers just keep pointing to each box. Right? Now we said 1 times 4. Like file pointer actually finished reading that. Is point to when you read in, it start to point to the first beginning of this next section, right there. So right after we do read in, is pointing right there. Prepare to read the next one. Now if we say input 1 times 4, pretty much it is 4. So this is 0, 1, 2, 3, 4, right? That's the index, right, of byte 0, byte 1, byte 2, byte 3, and byte 4. So that's why it pretty much just moved the file pointer into that location, same location that first after it read in, same that's left out. Now we're going to say in out.readInt. So this file pointer actually going to read the contents and move it to the next one. Now the content display on the printout 1. So now we're going to say 9 times 4, 32. So we're going to move, like instead of keep moving 32 more, no, it's going to seek to the location where it say 32. Start from the beginning, right? So this is 4, 8, 12, 16, right? It's every 4 and 9 of that, right? 36, right? 9 times 4, which is every 4. This is 4, 1, 2, 3, 4. And 9 of this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? So let's move it right at the end of 9, which is that end of 9 means what? Beginning of this point. So it moved there, right? And once it moved there, let's say read in. So that's why it's printing out 9 contents, because it's moved to that location, and 9 being printed out. After it's print out, it's just move it to the next one, correct? Because read in move the file pointer. Now we say we are write in 555. So that means we're going to write the contents 555 right there. So 555 is down there, replacing 10. Right, so 555 is there. After it's right, then it moves your pointer down again. So your pointer moves down here and it contains 555. Big word. Right? Because it's right and move every 4. Alright, so next we're going to read this code line 34. We said we move the file pointer. In out.seek is the one who moved the file pointer where? In out.length, which is 800, right? In out.length. So it's going to move to 800. So pretty much at the end of the file. That's what it is. So we move this file pointer to the end of the file. Right? Because every 4, 4, 4, 4, and 200 after is 800. So it's going to be at the end. Right there. Right? So this is the file pointer being moved here. And what do? We can write in 999. So we can write pretty much just append the data right there. And after append 999, file pointer move into the next, right? At the end of that file again. That means you can keep appending now. We don't have to move again. But what it's going to do is say, hey, I want you to print the length. Okay, so the length now should be 800 plus 4 more, right? Because we write in, so that's 4 bytes. So we have 804 printing out. That's why we have 804. And now the code say, hey, I want you to move your file pointer back to location 10. So 10, right? 10 times 4, everything is 4. go back to 10, so we can just go back to location 10 at the end of the 10, right? That means we go to 1, 2, 3, 4, 5, 6, 8, 9, 10. Where you move, it's going to move to the end of the 10, which is pointing to this contents. Now file pointer going to print in out.read, because file pointer is printing out to this content, which is 555, right? So 555 is being printed out, so that's why we have 555. Alrighty, and then we're done with the program. Okay, for the address book, to see, we can write application. Let us use random access file to create a useful project for storing and viewing an address book. The add button stores a new address to the end of the file. First name, first, next, previous, and last button retrieve the first, next, previous, and last addresses from the file respectively. So we can look at the application. You can review that from your textbook. Okay. Fixed length string I/O. Random access files are often used to process files of records. For convenience, fixed length records are used in random access files so that a record can be located easily. A record consists of a fixed number of fields. A field can be a string or any primitive data type. A string in a fixed length record has a max size. If a string is smaller than the max size, the rest of the string is padded with blanks. So this is a fixed length string I/O. Class. Address implementation. So the rest of the work can be summarized in the following step. Create a user interface, add a record, read a record from the file, write a code to implement the button actions. So address book extends JFrame. So this is looking like using swing. So this whole code is using swing with the buttons. Use random access files to help to search for address. Okay. So this whole thing is just pretty much the code for that application. For address book here, case studies. But this is all swing, not JavaFX. And then we are done with the chapter 17, BinaryIO. So now I would like you to review the code for this by yourself, okay? This is just make an action listener, but this is all in swing. You pretty much just need to have the basic of how you swing. But it's very similar and easier than JavaFX, so it should be very easy to look at. Alright.